So the C language has a number of keywords that represent data types. There are many more that you'll find in libraries and whatnot, but for the basic sort of core standard C, you'll find these keywords here. Int, char, short, double, float, and void, right? And so what these are, they are simply data types that, for instance, if we use an identifier for like a variable, they sort of let the compiler know how many bytes we're dealing with, right? So saying that an identifier is really a good way of thinking of an identifier or a variable name is it's just some human readable identifier token that says that is sort of references some memory location. And so how we know how much data is there is really where these keywords come in, right? And so the compiler says, hey, at this memory location, like at this variable, which is stored somewhere on our system, there is an integer. So there's generally on most systems this will be 4 bytes. Which sort of brings me to the next point, is that, like as I was saying, these keywords determine the amount of data, the amount of bytes. It's all bytes. How many bytes that this thing needs, this variable or this function returns or what have you, this keyword. So right. So an integer being one of the most common data types we'll probably ever come across. The actual size of them is very much compiler dependent, right? So as we see here, the compiler implementation depends on the operating system or the hardware. For instance, if we're an embedded system, we might not have an operating system, right? But the hardware itself can support certain integer sizes. And so if we see here on the last point, the compiler is generally created for a platform, whether it be just a 64-bit x86 Linux system, or if it's for a 32-bit ARM Cortex M4, right? So the compiler knows what it's targeting, which we mentioned in the sort of last compilation lecture where we talked about cross-compilation. And so the compiler itself knows how big the integer on the target system should be, right? So for instance, on my laptop, which I'm recording this on, I'm on a 64-bit, like most modern, like pretty much all modern laptops. It's an x86, so it's a standard sort of Intel AMD CPU. And so because it's a 64-bit system, it defaults to having a 64-bit integer, right? Now on a 32-bit microcontroller, you'll find the integer is 32 bits. And so this impacts the sort of the variable range that it can store, like the actual range of the numbers. But you also have to be aware of this. Like you should understand that if you're writing portable code for your C code might be compiled for multiple platforms, that the integers sort of range is not always going to be the same necessarily. So we'll look into on the next slide the sort of details of each certain one. But these types can be classified into a few sort of different types, right? So we have the basic types. So these are arithmetic. So these are integers, floats. These are just numbers, right? So we have 1, 2, 3 integers, floats being decimal. So 1.1, 2.2, 1.2, 4, 5, 6, 7, 8, what have you. What we use for generally storing like most data, right? Then we have enumerated types. So what these are known in or stored in C using the enum keyword. And so the enum keyword creates an enumeration where we can sort of fix some sort of, for the program, a human readable variable name, sort of data or like value to, and it actually works out to be some sort of an integer value which stores, which represents something. It's a bit confusing, but I'm going to do an example in a minute, and I'll go through this in a code example. Then we have the void data type. Now the void data type on C is used for meaning nothing. So if it's like a return from a function, it could mean that there is returning nothing. If it's the parameter function, it'll mean this function takes nothing. Or if it's a pointer, it means that this pointer, which we'll get to as well, there's not actually anything stored in this, right? It's empty, it's nothing, right? So that's the void data type. And then we have the derived data types. And so these, which we'll get into a lot more, especially pointers and structures towards the very end of this sort of lecture series. these are more advanced data types used within C, right? So now, looking at the arithmetic types, as I mentioned before, there's the most common ones that you'll find are integer, char. Short is also another sort of default one. It's generally not used as much. It's good if you know that you're going to have a very small number that's maybe too large for 8 bits, because char is like, for instance, 1 byte. It's always 1 byte. It's just, you can use a short to sort of save a bit of memory space, right? Depending on system alignment, memory alignment, blah, 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 what have you. But like a character is generally, as the sort of name says, it's used for storing 1 byte. A char and why it's called a character and 1 byte is because it's an 8-bit generally, or I mean, if it's used as a character, it'll be an 8-bit ASCII code. And the ASCII codes, there's not that many of them. There's like 100, what have you. There's no more than 256 because it stores 0 to 255 if it's unsigned, and if it's signed, such as this one, meaning char, because there's no unsigned, it means it can store minus to positive. So it's 0 in the middle, and since it has 256 values of resolution, it can go down to minus 128 and up to 127, right? Then we have sort of like the unsigned variants of all of these, and all that means is it sort of says, okay, we're not going to put 0 in the middle of our range, 0 is going to be the beginning of our range, and it's just standard binary, right? So like, 1, 1, 1 is, 1 plus 2 plus 4. It's 7, right? So when it comes to signed, then you have the whole floating point, what have you, that I can't remember from my undergrad years and years ago, right? So then the only other one that you really get, and this is sort of rarely used, is the long. And so long, as it says here, is 8 bytes, and it's used to store these massive values, if you need them, right? So one thing which we'll see in my example, which I'll do in a minute, will be the size of operator. Now the size of operator is really useful in C because obviously we need to know how big things are. Like, we want to write portable code, so we're not going to say allocate me an integer there and just put it in a 4. Because what happens if we're on a different system where an integer is 8 bytes? Then our code is no longer valid. So we want to say, we'll put instead of 4, which we think on a microcontroller is the length of an integer, we'll say size of int. And so that means that we recompile our code for a different hardware platform. We are dynamically, or we've written smart code that can actually adapt to the changed hardware platform that, for instance, might have bigger ints, right? So the void type. Void pops up in like a few different places in C, but for if we sort of ignore this one, because until you know what a pointer is, it will be sort of hard to explain what a void pointer is. We have functions, as we saw in the Hello World one here. Our main function returned an integer. So what it says is that when it returns a number, like when your program is running, wherever this function was called from, it will return this value. So for instance, the main function of our program was called from the operating system. So when this program terminates, this 0 is returned back to our operating system, right? Void functions, such as the one we can see here, all it means is the function doesn't return anything. It returns nothing. And so we don't have a return statement. There's nothing here. You can write return, but you can't write return 1 or return 0. You can't give a value because it doesn't return anything. It returns nothing. And similarly to the return value, we have the function arguments. And so these ones that you find here. And so these are the arguments, the parameters, the variables that are passed into the function. So when we do function, we'll talk about functions a bit more in depth very soon, but you can also have functions that don't take in any values. Like, so they take in void, they take in nothing, right? And so that's the void data type. It's generally just used for saying, I don't care about, like in functions it says, I don't want to return anything, or I don't take anything in as a parameter. I take nothing. So they'll go into variables. And what I'm going to do now is I'm going to jump into the computer and do an example. If I find my mouse.